Good morning, everyone. My name is Raffaella Taddeo, and I'm from University Gabriele D'Annunzio of Chieti Pescara, Italy. Today, I will show you the research that I conducted with my colleagues Alberto Simboli and Veronica Casolani. The title of my presentation is Commodity Prices and Trends in a Globalized and Circular Economy, a Local Perspective. This research is inspired by the trends in the prices and availability of raw materials that have been witnessing in recent years and is a part of a more broad analysis concerning the search for solutions able to provide a greater efficiency in the use of resources, which finds now its highest expression in the circular economy paradigm. The research presented here intends to highlight the main technical, economic, and environmental potential and criticalities of these options and propose an eco-industrial perspective of analysis for the enhancement of local economies and territories. In recent years and as never before, temporary and structural events such as natural disasters, logistical and distribution problems, socio-political and pandemic situation, the depletion of supply sources had a negative impact on the availability and prices of many raw materials. As you can see also in this slide analyzing the data provided by the World Bank and NASDAQ, it is evident that for many raw materials and resources for industrial use, to an ever-increasing underlying trend, periodically sudden changes linked to temporary phenomena are added up to a rapid surge that characterized the last 2 years, with increases reaching 2,000% of the average price prior to 2020. In the light of this, it becomes essential to broaden the perspective of analysis to consider the environmental and more generally the sustainability of the phenomena described in order to include the new paradigm of circular economy. As we know, the concept of circular economy has been spreading widely in recent years, and it summarized the current need to move towards a more sustainable socio-technical system. Circular economy entails a systemic transformation of the whole economic systems at various scales, covering the phase of production, use, consumption, but also end of life. In this way, the value of material and energy flows are maintained in the technosphere as long as possible while reducing environmental impact in terms of resources depletion and pollution. The main benefit that can be achieved through the implementation of circular economy practices can be the reduction of extracted raw materials, the reduction of energy consumption related to the extraction phase, the reduction of transportation impacts, but also the reduction of impacts during the phase of processing of these materials, and the reduction of materials to be disposed of at the end of their life. Numerous efforts made worldwide to facilitate the transition process towards circular economy, we can say that we are still far away from a real circular economy. In fact, if we analyze the circularity gap report data, we can notice that the world economy is only 8.6% circular. This means that there is a circularity gap of more than 90%. In addition, in this research has been highlighted that by 2050, the material use will amount to between 170 and 184 billion tons, and this value can be compared to the value of 2015 when the material use was about 84 billion tons. So to ensure that the implementation economy solution is effective as well as efficient, there are some conditions that must be respected. From a technological point of view, we have to take into consideration that the closed-loop technologies must guarantee the restoration of suitable conditions of usability of products, components, and materials. The closed-loop process must have also less impact than the primary production process, and this can be measured through a life cycle-based analysis. And the closed-loop flows must be compatible in terms of volumes, temporal distribution of flows and stocks, but also variability with the processes it will feed. But we also to consider also economic aspects such as those related to the prices of secondary raw materials that are influenced by many factors like the prices of raw materials, the market demand and offer for secondary raw materials, low provision, technological development in terms of quantity and quality of processable raw materials and related costs, intrinsic quality of material such as the type of material or the process to which it has been subjected, but also the properties of the scraps like purity, size, or shape, and supply chain costs like the collection, transportation, and selection activities. So the question remains of what level of analysis is most suitable for the implementation of circular economy options. From the literature and also from practical experience, we know that someone is calling for initiative at a global level while others for a return to territories, emphasizing the key role played by the local dimension in this transition process. From our experience, the local scale system have greater potential of revaluation. In fact, we know that the overall picture is so complex that it is quite impossible to have a single large-scale model capable of covering all the aspects of circular economy and in a balanced functional relationship. So, moving from is proposed by industrial ecology, we consider the industrial system not in isolation but in concert with its surrounding. So in this perspective, we call for a local dimension of circular economy. Is also suggested by a study proposed in 2004 where it was analyzed the spatial analysis of this phenomenon, and it was demonstrated how at a regional level a fair compromise can be found between technological and organizational skills, but also between economic feasibility and the degree of involvement of the actors in the implementation process of this kind of initiatives. The empirical derived also from our studies highlight that the local territories, and in particular such contexts characterized by the co-presence of different dimensions such as the industrial, rural, agricultural, and urban dimension can express a great potential in closing the loop of materials. In this figure, you can see the main results of our study, which started with a retrospective investigation of such local context and continued with the development of a specific approach based mainly on contribution from industrial symbiosis and urban metabolism, and an analysis for the specific synergies that are potentially associated. The study demonstrated that the presence of the different dimensions can be useful for efficiently identifying and managing material and energy flow, and also for developing improvement action favored, for example, by greater heterogeneity and proximity, along with more effective policies for a sustainable local development approach in a circular perspective. To conclude, we can say that the scale of humanity's metabolism is now unsustainable and must be reduced. Promising opportunities are at the territorial scale of analysis or the mesoscale recognized in literature, in which networks of complementary entities perform complex function. At the mesoscale, in fact, IT's efficiency are achieved in the development of closed-loop initiative, both for the organizational managerial complexity connected to them and for the availability of flows and technological skills for their realization. So the future developments of these research will have to go beyond the perspective vision of such scenarios to include the option for closing cycles in models that can effectively support the decision of sustainable economic growth at a local and therefore global level. Would like to thank you for your attention, and if you have any question, you can use my email address to write me. Thank you.